All right, let's hop into number 2 together. So the first thing they tell me is given that tangent theta is equal to square root of 3. Before I even do anything else, I'm noticing that tangent of theta is positive. So I would have drawn my ASTC, and I know that I have to be probably in quadrant 1 or quadrant 3. But then they also told me that I'm in quadrant 3, so that just makes life even simpler for me. So in quadrant 3, tangent is positive. So I know that tangent is going to be positive, and I know the reciprocal of that, cotangent, is going to be positive. So let me go right down to the bottom and take care of that one time. I'm going to have a plus here. I'm going to have a plus here. Everything else is going to be minus. Me doing this step earlier saves me work later on. Now I'm going to draw my triangle based off the information that I'm given. So I'm in quadrant 3, and I just draw my triangle right there. I'm going to put my theta here, got my right triangle here. Now over here they told me that tangent, or TOA, is equal to the square root of 3. Well, what's the denominator of square root of 3? You're right, it's 1. So square root of 3 over 1. So that means opposite over adjacent, which is TOA, is equal to square root of 3 over 1. So my opposite is square root of 3, and my adjacent is going to be 1. Cool. We got that locked in. So then now what we need to find is my last side. So what are we looking for now? Are we looking for a leg or a hypotenuse? You got it. We're looking for the hypotenuse. So let's go ahead and plug in to our Pythagorean theorem. So it's going to be 1 squared, and then the square root of 3 squared equals to x squared, because we're solving for that hypotenuse. So if I continue breaking it down, I'm going to have 1 plus the square root of 3 to the second power is going to be 3 equals to x squared. Then we're going to have 4 equals to x squared, and then we're going to have square root of both sides now. It's going to give me plus or minus 2 is going to be equal to x, but we're just going to use a positive 2 because we're talking about a length. So I know that my x is equal to 2. I could draw my triangle once again. So the same triangle that I have here, I'm going to bring it down. But I'm going to label all my sides. Okay? So I'm going to have square root of 3 right here. I'm going to have 1 here. And instead of x, I'm going to have the 2 that I just found. Everything from here becomes quite simple. Okay? Let me label the sides to make it simpler. If theta is here, I know this is my opposite side. We know the arrow here points to the hypotenuse. And then over here is my adjacent. Okay? So what's the sign? Sine is opposite over hypotenuse. So that's going to be square root of 3 over 2. Okay? So the cosecant, we know, is the flip of that. So that's negative 2 over radical 3. But I got a question for you. Is this the final form we want to leave our answers in? Okay, well, if it's not the final form, why not? Got to rationalize the denominator. Means getting rid of the radical that can't be simplified at the bottom. So we're going to multiply by radical 3 on the bottom and the top. And we're going to get negative, don't forget that, 2 radical 3 all over radical 2 times radical 3. We know that becomes radical 9, and we know that will just become 3. Cosine theta. Well, we know that's co. So that's adjacent over hypotenuse. So that's just going to be 1/2. The flip of that, or the reciprocal of that, is going to be negative 2 over 1. Done deal. Tangent theta. We know that's opposite over adjacent. So the first one is just going to be square root of 3 over 1, which is just going to be square root of 3. The flip of that is 1 over square root of 3. We need to rationalize this denominator. Multiply by radical 3 on the bottom and the top. We're going to be left with radical 3 at the bottom. And in a similar fashion, radical 3 times radical 3, we know that gives us radical 9. And radical 9 is just going to give us 3. Second question all done. It's quite a few steps, and it combines a lot of different pieces of knowledge that we learned throughout the semester. But if you do it piece by piece, it'll stay simple. See you in the next question.